On this slide, you're looking at the data from a table called departments. It has the columns department ID, department name, manager ID, and location ID. We'll concentrate on the manager ID column. The values taken by this column are employee ID values from the employees table. That is, an employee of the company is the manager of a department. Notice that some of the manager ID values are null, and this would imply that these departments do not have a manager. Now here is the query that you would have written to identify the name of the department and the first name of the employee who manages the department. I'm going to read the select statement. It goes as select department underscore name, comma first underscore name from departments D, employees E, where manager ID in the departments table is equal to the employee ID in the employees table. So the relationship is based on the manager ID column in the departments table being equal to an employee ID in the employees table. And this is actually an example of an equi-join being performed. When the query executes, the query will return a result where you're going to get all the departments that had a manager ID only. What if you wanted to display additional information in the result where you want to see, in addition to the departments that have managers, you also want to see the departments that did not have managers? What you would have had to do is extend this output and get additional information from the departments table that does not have corresponding information in the employees table. And what you would have had to do is create a type of join known as an outer join. So the outer join is always built over and above a join called the equi-join. The outer join is done with the use of an operator known as the outer join operator. This operator is open parentheses plus close parentheses. If you want to display the departments that do not have manager names, the value of the first name should appear as null in the output. In the query that forms the equi-join, you would include the outer join operator on the side of the condition that identifies the table that does not have the values to display. Have a look at the join condition in the query. It's written as where d.manager_id is equal to e.employee_id. The table D stands for the departments table. The table E stands for the employees table. In the output, the department name comes from the D or the departments table. In the output, the first name comes from the E or the employees table. So the table that does not have data to display in the output would be the employees table, because we would not have any first names to display for certain departments. Notice where the plus operator or the outer join operator has been placed in the condition. It has been placed on the side of the condition where the table E has been written, or the employees table. Also observe the output. Some of the departments have first names associated with them, while others have null values associated with them. This type of an output is being retrieved because of the outer join operator. Here we have a query that's based on the employees table. The query reads as select employee ID, first name, last name, manager ID from employees. Now we are going to concentrate only on two specific columns, the employee ID column and the manager ID column. An employee's manager is always another employee. Now let's just consider the rows where the values are circled. I have a value 103 that's circled in the manager ID column that corresponds to the row where the employee's ID is 107 and the name of that employee is Diana. Now Diana's manager is the employee whose ID is 103 and the name of that employee is Alexander. When you want to retrieve data from a table in such a way that all the data is not in a single row and the necessary output comes from different rows in the same table based on a value relating the rows, you have to create a type of join known as a self-join. Self-joins are sometimes also called as inner joins. This involves using the same table name with different aliases and relating the tables based on the values in each of the tables. Now on this slide, we have the same query being displayed twice. Each of the outputs have a heading which shows up as employees. However, the first output has the letter E beside the name employees, where we are saying that the letter E is the alias for the employees table. You have the second output which also has the heading as employees, but you have the letter M, which is the alias for the second output. Now, when you are trying to perform a self join, you would have to imagine that there are two versions of the same table. Give each of the versions a different name so that you can identify the versions by the alias name. The next thing you'll have to do is identify how the data in the first version of the table is associated with the data in the second version of the table. Imagine that the first version, that is called as E, contains employee information, and the second version, that is called as M in this example, contains the manager information. We know that an employee's manager ID is equal to an employee's employee ID. Here, what we have written is a condition that goes as E.manager ID is equal to M.employee ID. You can see an arrow that goes from the manager ID value to an employee ID value. Now, this type of a query where you are getting all the data from one single table but against different rows of the table based on a condition that joins the data on those two rows is known as a self-join. The query that you would have to write if you wanted to display each employee's first name and last name along with their manager's first name and last name would be written as select E.firstname, E.lastname, M.firstname, M.lastname from employees alias E, employees alias M, where E.manager ID is equal to M.manager ID. Notice this output, the row that has been highlighted, displays the details of Diana, where the first name is Diana, the last name is Lawrence, the manager's first name is Alexander, and the manager's last name is Hunold. So this is an example of a self-join. In this tutorial, I discussed the theory behind joining tables. In my next tutorial, I'll show you how the different join statements will be performed using SQL statements in SQL Developer. I hope you find this tutorial useful. For other videos, tutorials, and articles, you can visit our website at www.oraclecoach.com. Thank you for your time and thank you for listening.